Okay, good morning for all of you. So uh, today we will start soon, yeah, at 9 o'clock. So while we are still waiting for the participants and also probably for the presenter. Okay, so this morning session will be the last session for in the topic cybersecurity and AI and artificial intelligence. And we start with our invited speaker, Dr. Anto Satriyo Nugroho. Maybe a few of you, some of you already know him in the class, yeah, for the IT student, of course. Uh, Dr. Anto Satriyo works for Center of Information and Communication Technology, agency for the assessment and application of technology, or in bahasa it PTIK, BPPT, Indonesia. He completed his Bachelor of Engineering on 1995 and then Master of Engineering on 2000 and Doctor Engineering on 2003 in Electrical and Computer Engineering from Nagoya Institute of Technology, Japan. And from 2003 to 2007, he was working as visiting professor at School of Life System Science and Technology, Tokyo University, Japan. His research interest is on the pattern recognition and computer vision with applied field of interest on multimodal biometric identification and computer aided diagnosis for malaria detection. He is currently the first president of Indonesian Association for Pattern Recognition, or INAPR, and an Indonesian governing board member of International Association of Pattern Recognition, or IAPR. Dr. Anto is also member of IEEE, Indonesian Association for Pattern Recognition, Indonesian Association for Computational Linguistics, and Indonesian Society of Soft Computing. So we are honored to have Dr. Anto as our invited speaker here. And the topic will be more to the biometrics, biometric technology for the better public services. So we have around 20 minutes and then we will continue with the question and answer. Pak Anto, please, time is yours, Pak. Thank you.
Thank you very much, Mr. Chairman Pak Maula. I will share my slides.
Yes, Pak, please.
Okay. Good morning, ladies and gentlemen. My name is Anto Satriyo Nugroho. My name is Anto Satriyo Nugroho from Center for Information and Communication Technology, Agency Application of Technology. My talk today, the title, Biometrics Technology for Better Public Services. I've been working for BPPT around more than 30 years, and currently my focus is on pattern recognitions, particularly on biometrics identifications, which becomes the focus of my talk today. The agenda of my talk is biometrics for electronics identity card, or KTP-els, performance assessment of Indonesian's EID reader, and usage of biometrics and KTP-el for public services, biometrics research in Covid-19 Pandemy. Okay, what is biometrics, by the way? Definitions of biometrics is identity using his or her physiological and or behavioral characteristics. Many of us use biometrics in daily life. For example, face recognition in Facebook that can detect the face in the picture that we upload. Also, fingerprint recognition for attendance systems, and most of us now had KTP-el, or Indonesian's EID, that use biometrics to avoid duplications. Biometrics is very important tools for authentications. There are three methods for authentications. The most primitive one is based on what you have. For example, user ID, ID card, and many others. This method is simple and used from the past, but it has several weaknesses. For example, it can be shared, it can be duplicated, and it can be stolen. The second method is based on what you know. For example, password, PIN, personal knowledge. But it is again has several weaknesses such as can be shared, can be forgotten, can be guessed. The third method is based on who you are. The example is biometrics. There are several advantages of using biometrics. It cannot be shared, cannot be forgotten, cannot be stolen. The available of data used for authentication is very important. The data collected in KTP-el program is one of the biggest database in the world. The scale is still larger than US Ident, UFACE, and FBI office. KTP-el is in the second biggest data. It is used for deduplications to avoid persons to have multiple ID. This is the duplication flow. The citizens is enrolled in sub-district or kecamatan. The biometrics data consists of 10 fingers, 2 iris, face, and signatures. They are sent to the data center, being compared with all biometrics data stored in national database to ensure the uniqueness. If the duplication result is unique, the card is issued. Otherwise, it is classified as duplicated identity. Only fingerprints data are stored in KTP-el chips, left index finger and right index finger. And the minutiae information or the template of the finger is stored in ISO IEC 19794-2 format to maintain interoperability with templates which is generated by the other algorithms. A three-level information is information available in the fingerprints. The first level shows the overall global reach flow patterns. Level 2 is minutiae patterns. Level 3 is the sweet pores. The first level is the information which can be seen under low resolution, for example, 200 dpi. It is, for example, singular points, course, ridge line shapes, and the other informations. It can be used to differentiate 5 classes: left loop, right loop, whorl, arc, and dented arc. The second level is minutiae, which requires 500 dpi. It has two most prominent ridge characteristics. The first one is ridge ending, the red one, yeah, and the ridge bifurcations, the blue box. The number of minutiae points is around 60 to 70 in our fingers, and it is stable, robust to fingerprint impressions conditions. The third level is sweet pores information that can be seen with high resolution imaging. It needs 1000 dpi to extract the informations. To give you illustrations how fingerprint used to authentications, please look at these examples. The first is genuine matchings, fingerprint that comes from the same finger. If they are compared, there are a lot of matching minutiae. In these examples, 31 matching pairs were found. The second one is the impostor matchings. If two fingers that come from different fingers will produce few matching minutiae. In these examples, 6 matching pairs were found. Based on these principles, Indonesia's EID reader is used to read the resident's EID from the chips. This is the flow to read the data. It has 2 steps authentications. The first step is mutual authentications to check whether the card is valid or not. If the card is valid, then the information is sent to the next steps, biometrics authentications. The residents is required to place their index finger in the scanner for being matched with the fingerprint data in the EID chips. The first examples, I will put my card and the KTP-el reader asks me to scan my right index finger. So my right index finger is requested to place, but I put the wrong finger. I put my left finger. As a result, the verification is failed. The reader then asked me again to put my finger, my left finger. I put my left finger and success. My identity can be read from the card. This is the biometrics testing that many industry has already produced the EID reader. The reader should be tested to assure that its specifications comply the regulations of Ministry of Home Affairs number 34, 2014. As described in the regulations, several items should be checked and evaluated. For example, the matching result should be included or should be 10 not as a top 10 in the world as announced by National Institute of Standard and Technology Internal Report or NIST. And also the data should be stored in the chips, follow ISO IC 19794-2. The third is important conditions that the false rejection rate is maximum 3% at false acceptance rate 0.01%. To give you illustrations, the difference between manusia from one finger, the same finger extracted by two algorithms, FIS1 and FIS2, compared with those of KTP electronics. FIS is abbreviations of automated fingerprint identification systems. The slide shows that the same finger is extracted by different extraction algorithms will produce different minutia set. It is important to evaluate the minutia extracted by vendor algorithms will match with the minutia which is stored inside of the chips. NIST also reported the evaluations of minutia generators by its vendors. This is the list of top algorithms produced by the vendors reported by NIST. NIST also reported the evaluations of template measures by the vendors. This is the list of top major algorithms produced by the vendor as reported by NIST. To evaluate the minutia of vendor algorithm, we use 3,000 persons using stratified sampling to the available data, which is more than 13,000 pairs. We maintain the proportions of data quality as measured by NIST fingerprint image quality or NFIQ from 1 to 5. 1 shows the best quality fingerprints, while 5 is the worst. We made 3 scenarios to evaluate the performance of vendors' EVIS SDK. This is the first scenario. We use a large-scale fingerprint data obtained from Indonesian KTP electronics, but the minutia are generated using vendor proprietary algorithm. Raw image was obtained using KTP-el scanner, not the vendor scanners. Minutia extractor and matcher use a vendor proprietary. Pros of this approach is that the performance evaluations should use a large-scale fingerprint dataset, which is 3,000 pairs. The cons is that it does not represent the real situations since the matching was not conducted in cross-template matchings. This is the illustrations of scenario 1. We use raw image which is scanned by KTP-el scanner we obtain the dataset from Directorate General of Populations and Civil Registrations, Ministry of Home Affairs. The raw images are the input and feed the vendor's minutiae extractors, which is proprietary format. Fingerprint matching is conducted using vendor's measures. The second scenario, it is end-to-end testing. We use raw image, which is scanned by KTP-el scanner. It represents the data inside of chip KTP electronics, and the other one is scanned by vendor sensors, which is installed in device under test. Hence, we perform cross-template matching that represents the real situations. Unfortunately, such a testing is only conducted by small scales. We invited 50% to do these experiments. This is the illustrations of the scenario 2, that the fingerprint matching is conducted using cross-template matching scenario, and the minutiae is stored in ISO IC 1979-4-2 format. This is the third scenario. It combines both scenarios in the previous slides. This scenario uses cross-template matching in ISO template, similar to scenario 2, and large-scale dataset is conducted in scenario 1. This is the illustrations of scenario 3. The limitation of this scenario is that the fingerprints were scanned using the same fingerprint scanner which is used in KTP electronics. It is because we want to use large-scale datasets for the performance measure assessments. This is the result of biometrics testings. The two errors, false rejection rate and false acceptance rates, were calculated using 3,000 pairs, fingerprint pairs, and the receiver operating characteristic is plotted. False rejection rate is situations when a person uses his finger for authentications but rejected by the systems, while false acceptance is a situation when a person uses the other person's EID for authentications and success. When the threshold is set as at 120, false rejection rate is around 0.5%, when false acceptance rate is around 0.01%. This means that the performance satisfied the requirements of Directorate General of Populations and Civil Registrations, Ministry of Home Affairs. This is the illustrations of the false rejection rate and false acceptance rate. Horizontal axis shows the matching threshold, while vertical axis shows the probability. When the matching threshold is set at T, false rejection rate is the area in the left side of the threshold, the red ones, yeah. Of the genuine, while false acceptance rates is the area on the right side of threshold T of the impostor matching score frequency distributions. We also measure the ratio between class variance and within class variance. The ratio between class variance and within class variance is defined as the formula as shown in the slides. The greater value of J, it shows the better the performance of vendor's SDK. This is how the second scenario, end-to-end testing, is conducted. 50 persons are invited. Each person is requested to use the KTP-el reader device under test, or DUT. The matching scores obtained by the device and those by SDK PC are plotted to show how they correspond each other. We have already completed biometrics testing for 28 industrial clients. It is the current status of KTP-el reader. Directorate General of Population and Civil Registrations of Ministry of Home Affairs reported that 162 institutions already use the readers. Indonesian Police, Bank, Social Security Organizing Body or BPPT, and many other institutions are already use the reader for authentications. This is one of our activity to use KTP-el reader for voter verification in Jembrana, Bali. The voter is doing the authentications before they make the voting. The aim of this process is to make sure that the voter is valid ones. The voter is done by the right persons, so illegal voting can be avoided. The biometrics data collected by Ministry of Home Affairs are used by the Indonesian police for identifications of air crash victims. They use MAMBIS. MAMBIS is Mobile Automated Multi-Biometric Systems, identification system, to scan the finger of victim and then send the finger data to the data center and obtain the personal identity as a result within seconds. Indonesian police has used MAMBIS for identifications of Air Asia crash victims and also murder of victim investigations. This is one example of murder victim identifications. The identifications is conducted using his finger to find the identity and the result is shown. Several standards is also available in biometrics. Some of them are already adopted to Indonesian standards. Biometrics vocabulary, finger minutiae data, finger image data, and face image data is already accepted to become Indonesia's national standard. Meanwhile, the voice data is still ongoing. In the end of this presentation, I want to show our current projects on biometrics. Currently, all over the world are in pandemic situations. These situations has already changed our life. Many of us are working from home. We have developed also face and location-based attendance systems to monitor the employees which is working from home. The attendance systems, which is modified fingerprint-based authentications to face-based, which can be authenticated remotely. Let me show you the illustration of the projects. First, the staff should place her face in designated area. Second, smile. This is used to make sure whether the face is genuine. If success, the location is recorded. This means that the staff and her location information will be stored in the database. The slide shows the client and the server. In the client side, acquisitions of employees' face is carried out. The information is sent to the server. There is two informations, that is face and identity number or NIC. A server will receive the image and the number and do the segmentations, face resize, and feature extractions. The feature of this face is 128 dimensions and being used for authentications. We use deep learning neural network in these projects, and the face recognition is conducted in one-to-one fashion. We evaluate the performance of the systems. The probability density function of genuine matching score and impostor matchings are shown in the slides. The genuine matching score is not smooth, black ones, because it is not easy to obtain more than 3,000 genuine matching scores. Instead, we obtain only 249 genuine matchings score as shown in the graph. Okay, this is the conclusion of my presentations. Biometrics receive increasing attentions. It plays an important role for duplications. And our office, PT-ICA BPPT, completed testing of KTP-el reader from 28 industrial clients. Biometrics has already used for electronic identity card, smartphone, forensic identifications, voter verification, and various public services. And face recognition received many attentions since it can be used for remote biometrics authentications. Thank you for your attention.
Okay, thank you, Pak Anto. So For the audience, okay, there is one questions. How the reliable is the finger itself? And what about people who have lose their fingerprint due to the abrasion or acid? Can they still use the scanner? Please, Pak.
Yeah, thank you very much, Diondra. That a good it's a good question that because biometrics is not always available for every person. So in IKTP we use several gate multi-biometrics, for example, 10 fingers to iris and face and also signatures. So in that case, for the duplications process, if the fingers is for some reasons cannot be used for the duplications, we can use the iris or face, yeah, for the duplications. And also, but for the reader, for KTP electronics, for persons who did not does not have a finger, of course, his finger is not recorded. Or if index finger is not good quality, then the system will ask to the best among the available fingers to being saved in the chip of KTP electronics. Uh, from the study of NIST, around 2% of the peoples in the world are has not good quality of fingerprints. It is called as Rottington Zoo. Yeah. In that case, of course, we using fingerprint is not recommended. So for the duplication, it can be used. We can use face or the iris of the peoples. I hope it answer your questions.
Okay, thank you, Pak Anto. Another question: which biometric, Pak, is the most accurate and then difficult to be duplicate or fake?
Yeah, among several biometrics that we have, that among the face, fingerprint, and iris is the most difficult biometrics to being duplicate, because if a person want to make a duplications of make a modifications of the our iris, it is very high risk. Yeah, finger is a bit easy to make fake versions of the fingers, because we can a person can use exit, yeah, to make to change the pattern in the fingers. But for iris, it is very difficult, and it is recognized as iris is recognized as the most stable, as the best biometrics. But the cost is very expensive. The scanner is more expensive compared to face and compared to finger.
Okay, thank you. Is there any other question from the floors? Okay, I have a question, Pak. How is the current progress for the, though you already mentioned about the KTP electronic reader, but as the public services, I haven't seen yet, for example, in the banking system or in the maybe the check-in for the flight, for example. How is the progress, Pak, for the public
Yeah.
service, more to the public service?
Okay. The bank already use the reader, but not for common people come to the banks. But for the people who apply
Okay.
want to rent money, yeah, from the bank, then fingerprint reader is KTP reader is used to for authentications. A KTP reader is also used for voting in some Pemda, and also used in police. I have seen that police in Karanganyar at the times, they already use a lot of KTP-el reader for people who apply SIM, yeah, in a driving license before. So they should they should use the reader for authentications their fingers.
Okay.
There's
Thank you.
the several examples of the usage of iktp readers.
Okay, thank you, Pak. But since
Hmm.
we are now in the pandemic, is there any the reader that touchless?
No, no. The current reader that is not the touchless ones. This is why
Okay.
in our idea we propose to use remote biometric authentications. We use face for authentications,
Face,
but again, in that case, we have to obtain the permissions from the Ministry of Home Affairs so we can access the data, the biometric data, to make authentications. We have already presented our paper on remote biometrics authentication yesterday. We succeed to make use face for authentications, but again, it depends on the Ministry of Home Affairs whether we are allowed to access the database or not.
okay. Thank you, Pak Anto, for the time. So since we are only have 30 minutes, yeah, we are sorry that we need to stop for the QA for this the invited speaker, Dr. Anto. So you could still private chat with the Pak Anto. Just send the email